Hello, everyone, and welcome to Microchip's Shields Up webinar series. My name is Megan Walton. Our presenter for today is Xavier Benyolet. Xavier is a Security Product Marketing Manager in charge of the Secure Element portfolio at Microchip Technology, with more than 15 years experience in the semiconductor industry. During the last 5 years at Microchip, he worked with global teams to develop the secure IoT authentication architecture used in the market today, as well as focuses on counterfeit protection for disposable and accessory systems. Today, we'll be covering session number 23, Counterfeit Protection for Disposable Applications. Without further ado, I'll turn the presentation over to Xavier. Thank you and enjoy today's session.
Thank you, Megan. So when we talk about disposable and consumable, we want to define, I want to give you an idea to the audience of what are the end product, the applications that we've seen our clients using our technology for, and then we talk about insulin pen, handle color spray, hair color spray, air freshener dispenser, medical ECG, printer cartridge, CPAP filter, electrode pads, and skincare brush. And those are only examples. And all of them have that notion of a cartridge that will be disposed at a certain point of time under certain conditions. Certain condition could be after a certain number of usage, after a single usage for safety reason, medical reason, user experience reasons. So one of the things, there are really four main things our clients are looking at. First one is protecting their brand and preserve the quality of their product, to avoid counterfeit, to avoid lower quality and lower performance, and make sure, or sometimes they also have a controlled ecosystem strategy, meaning their products will be extended to third parties that could manufacture products for that main brand, and then they want to control that ecosystem. The second one is revenue stream protection. There, we see our clients starting with authentication right from the start. It's not a question because it's part of their strategy there. What they want to do is to protect the user experience. So imagine their tablet and a keyboard, for example. So the striking experience of the hands on the keyboard, it's a firmware that controls that, and some companies do that better than others. So that's the IP that affects the user experience. They want to protect that because it's part of their revenue stream strategy. They also want to avoid discounted copy, and there we're really referring to copycats here. The third point is enabling service revenue streams. That's another thing. If you use that authentication notion, you can now think about maintenance service strategy, part replacement strategy. And the fourth one is make sure they use they have a low integration cost with an optimum form factors. In other words, what that means is how do you eliminate the PCB out of your bill of material that could be in your cartridge? There are ways to do that we're going to discuss in the presentation. And the cost reduction comes from really a cheaper mechanical integration at that point. It's not the semiconductor that the device itself is going to be slightly cheaper, but the rest of the system, the PCB, so the assembly and the way you're going to have the PCB inside an enclave that will have certain contacts, you get rid of all of that. That's where the cost reduction comes, and I'll illustrate that again later in the presentation. So what do all those systems have in common? All of them have a key, and what you want to do is protect it in a Microchip secure element. So Microchip has the crypto authentication device portfolio, which is composed of the ATSHA206, the ATSHA204, and the ATSHA206. All of them have different crypto accelerators. They are EEPROM based and equipped with side channel attack protection and active shield for anti-tampering. Philosophically, that's what it is. We have a variety of different packages, but note here the interesting piece with the ATSHA206, it comes with a 2-pin package and also for parasitic power. Now we're going to start, hopefully you start to see where I'm going in the presentation. We have a reference design at Microchip, a Nebulizer reference design that's accessible through microchip.com/medical that basically use a PIC16F. It's an 8-bit microcontrollers. So you have the entire block diagram here. And on the cartridge, on consumable, so right here, you have our ATSHA204, just to show you as a proof of concept how you can build such system. So if we look at the secure element, specifically the ATSHA206, what it has inside, it has a ATSHA256 crypto accelerator. It has a security prompt and a serial number in the monitoring counter. We're going to go a little bit deeper and deeper into the device, and then we'll talk about how to get started. So how do we use this ATSHA206? So ATSHA206 relies on symmetric keys, right? So what you want to do is build a bunch of challenge response pairs that will be programmed into the host microcontrollers to send a challenge and expect a response. The challenge will be passed through the ATSHA256 engine of the ATSHA206, and the ATSHA206 will use that customer master key that has been pre-provisioned in Microchip factories to send a response. If the response is the one expected, we authorize the device authorized disposable to dispense the gel, the liquid, the gas, whatever is inside the product. So in this case here, we have to accept that the host could be copied, right? So it is the decision of the client to decide of his risk tolerance on the host. Does he want, if the host is a highly valuable asset, probably want to have a different architecture, and that's where we're saying that alternatively, a ATSHA204 on the host could be used to protect the symmetric key instead of using pre-programmed challenge response in the microcontroller. So let's talk about those challenge response and what they are, because they could be a bit esoteric if we don't talk about it. So what it is in manufacturing, so at the customer site, what will need to happen is they'll have their customer master key, and they'll issue a random number. The random number is that challenge. So the challenge gets programmed into the host. And to get the response will be constructed by using the customer master key and the random number into a ATSHA256 algorithm to create a response. So now we have that challenge response pair that will be programmed into the microcontroller. So the idea is to generate a certain number of challenge response pairs that will be programmed into the microcontroller, and that's done offline or at Microchip facilities as we offer programming services. That's the philosophy. So you really want to take the right decision depending on how value you put into your host unit. Either you're happy with challenge response and it might be your host might be counterfeited, but the ATSHA206 here will help you that only one system will be counterfeited, not all of the disposable. And that's what we see generally in as the most cost-effective architecture. So going back to the ATSHA206, we look into the feature. Like I said, it has a ATSHA256 algorithm. It has 240 bytes of EEPROM for configuration. In the data zone, the memory is composed of data zone and configuration zone. You get 5 slots only of 32 bytes each, 32 bytes of 88 bytes for counting blocks and serial numbers on the config zone. It has a single wire interface with parasitic power. So what that means is you have the ground, and the second pin is where both the power will be supplied into the device, and on the same line, the data will go through that same line, thanks to the parasitic power capability of the device. It operates between 2.5 and 4.5 volts, and it performs under 150 nanoamp max sleep current here. We have 2 package options that are illustrated here. Both are 2 pins. We will call them the VSFN and the top side bottom here. We'll dive into the top side bottom concept here. That's pretty interesting. More about the feature, like we talked about, it's parasitically powered device with single wire interface. It's compatible with other crypto authentication device from library standpoint, and there is no external capacitor required. The SHA-206 is a shorter set of commands versus the SHA-204, and the configuration is fixed. So the config, you won't be able to change it. It has 5 dedicated slots, 1 for a symmetric key, the parent key, 1 for a derived key, and there are 3 slots for data slots. One always read-writable, and 2 lockable. You have a limited counter up that goes up to 1,024 users, but the limit can be set during provisioning to a lower value if you desire to. The derived key must be run after every authentication. The key updating is optional based on the derived key mode here. And of course, the device is supported by a CryptoAuthLib library that makes the secure element completely agnostic of the main controller, the host controller. From a feature set standpoint, again, if we talk about the parent key, it has a fixed value for given customers and customer application. It's programmed during provisioning, and Microchip will need to do the provisioning for this device, and it can support diversified key. For the derived key, it's a dedicated slot. We have a dedicated slot for deriving a key from the parent key like we saw in the previous slide. And the derived key is written during provisioning, again, done by Microchip. With regard to the data slots, we have 3 general purpose data slots for storing information. And we've seen clients asking the device to store various different info, such as the lot numbers, dates, and things like that. 2 of these slots can be locked from further updates with a write command. From a package standpoint, if we look at to prototype those challenge responses and stuff like that, sorry, I went in the wrong direction. The prototype units, so you'll get prototype units to get you started. They are pre-configured, like the one on the SHA-206 trust boards, which I'll talk about in a few minutes. It's available on the UDFN pin 8. So the UDFN here on the board, because you've seen those are only 2-pin device, we put a UDFN port that will be used only for prototyping. That's it. You'll never have a UDFN on SHA-206 in production. It's done only for prototyping. Generally, we've seen customers preferring that package for when they develop their POCs, to start their POCs. But immediately after, we switch to the 2-pin package mentioned here. The production units, they are configured based on the customer information. Of course, they're available in 2 pins, MBH and MGH, or really the name. So we find the top side, bottom, and the VSFN here. The UDFN, again, we're repeating, it's not supported for production. And the notion of blank device doesn't exist with the SHA-206. As we've said earlier in the presentation, it is a pre-configured device that you'll receive. So let's talk about parasitic power. So what it is, basically, you have a cap, an integrated capacitor inside the device. That's what it means, offering 2 different packages, 2 by 5 millimeters and 2 by 4 millimeters. The communication takes place over the SDA pin, and the power also will be supplied via the SDA pin. The resistor should be pulling the SDA line high only during the transmission of the data. So now, let's talk about mechanical consideration with disposables. Some application would require PCB, some wouldn't. Now, what do we do for those who don't? And then on top of that, we have to look at other factors. Sometimes there are space constraints applications, such as medical tube, and it's especially challenging to find a small enough form factor to achieve secure authentication. You want to ask yourself, the disposable can accommodate a PCB or avoid it? And paradoxically, smaller is not always better. We've seen applications, if you think about the printer cartridge, it demands a large contact surface of the pins that are going to make contact with the cartridge of the printer. They're going to make contact with the cartridge itself. So they are the notion of tolerance of the mechanical dimensions that kicks in now. And there is something else that happens in our semiconductor industry. The current contact packages in the market only have pads available on one side, the bottom, right? If you, or if not, you have pins that go outside. So the package solution we have presently, if we look at our crypto authentication portfolio, we have the SHA-204, C608, and SHA-206, like I said at the beginning of the presentation. We have the classic packages, but now we start to find that 3-pin RBH contacts for the SHA-204, which also exist in the 608, which I did forget here, on top of the classic UDF and SOICs. And that SHA-206 will have two new packages, the 2x4 and 2x25. Now, how do we reduce cost and simplify the overall system by eliminating the PCB? We're going back to the package, and we're comparing here the various crypto authentication devices one by one, and look at the type of packages that are generally used in cartridges. So if you use an RBH, VSFN, or top side bottom, there is no PCB needed, right? If you use classic UDFN, which we've seen, because, for example, we've seen UDFN being soldered down a PCB, and the PCB offers massive pads exposed to the rest of the system for better contact. So then, yes, you'll find PCBs. And I'll let you read all the dimensions and all the other ones. The Parasitic power is integrated in the SHA-206 with both packages. It doesn't mean it's not possible to have Parasitic power with the other cases, just you're going to have the cap externally. And so then you would require PCB from that point. So let's talk about the top side bottom. I was saying that's something quite unique where now, as you can see, you have, as the naming of the package mentions it, you have a contact at the top on the side and at the bottom of the package on both sides, obviously. So now it offers a new options of contact. And we talk about clipping mechanism with various techniques. You can have side contact, side and bottom, sit-in. You could do press fit with pogo on the top or the bottom. So now we don't talk about electronics anymore. We talk about solving the mechanical challenge of bringing those contacts into the disposable without a PCB. And that's a pretty elegant option that we're referring to the mechanical engineers. So for accessory and disposable, now we're going to talk about architectures between the host and the disposable itself. So if you have your microcontroller that use symmetric authentication and SHA-204, SHA-206, you'll have that notion of root share key or challenge response pair unique for each host. That's what we talked about right at the beginning of the presentation. And you have to accept there is a possibility of cloning the host micro, right? It's part of your risk assessment. But there, you're not going to be able to, it will be very hard to clone all the disposable if you use, especially if you use key diversification with the secret element there. You don't need the PCB either in that architecture. Still in the symmetric authentication realm, you could reinforce your system a little bit more and now add a SHA-204 on your host, on the host side of the system, by having the shared root key inside the SHA-204 secure elements. Now you have a better level of protection. It's for hosts that are deemed to have a certain value to the clients. And the challenge response remains pretty much use the same philosophy, except the challenge response will come from the SHA-204 to the SHA-204 inside the disposable. We continue in the symmetric realm as we're talking about our SHA devices. You could also have a 608, an ECC 608 here on the host instead of the SHA-204. Remember, the 608 has the SHA-256 algorithm integrated on top of the ECP256 algorithm. So what you can do is, if your host needs cloud connection, you could do a PKI to the cloud, a public key infrastructure mutual authentication TLS to the cloud, using the 608, and still using that 608 on the host. You can do that symmetric challenge to the disposable using the SHA-204. If we go a little bit further, if we switch to the asymmetric, it's a bit out of not out of topic, but it's a variant that we see our customers liking. It's instead of using symmetric authentication between the host and the client, they will use asymmetric authentication. In that case, we forget the SHA devices and we look at the ATSHA206A today that will basically bring you that public-private key authentication base. It will require PCB with the ATSHA206A in any of the cases. But you do have quite a stronger authentication, as you know, relying on elliptical curve versus a simple hash of a challenge. So how do we decide if the system requires, how do we decide what secure element to use and how if the system requires a PCB or not? So the first question we ask ourselves is, there a PCB on your disposable? Are you trying to avoid having a PCB in your disposable? If yes, we look right away at the, if yes, there is a PCB, look right away at the ATSHA206A, the SHA204 in classic packages. If the answer is no, there's no PCB allowed in the cartridge, so go to that next question, and what is the space constraint? Can you live with a larger RBH package that has 3 pins, or are you very space constrained and you really requires a 2-pin package and I have a parasitic power option? So if we're deciding to go through a larger package to have a larger surface of contact, 6.5 by 2.4 millimeters, if the size is okay, your SHA204 is the solution. Now, can the system tolerate 3-pin? Now we look at 2-pin options if it doesn't. So the 2-pin options are the 2x25 or the 2x24. Is the 2x25, which is the smallest device that offer top, side, bottom. Can the contact mechanism be developed and accommodated from a space standpoint, from a form factor standpoint inside the disposable? Yes, move the SHA206 TBS, top, side, bottom. If you need something slightly larger because your the geometry, the mechanical geometry, I would prefer something slightly larger, a 2x4, for example, then we go with a VSFN package. And also, when we see that decision being taken by our customers, that means the physical tolerances needs to be a little bit wider, larger than what the top side button would offer, as it's a smaller device. So from the mechanical skill sets, again, we talk a lot about mechanical, and it is the mechanical challenge is a huge part of the equation in this those type of applications. We have Microchip doesn't offer that, right? Now we get into the world of partners, and we have several partners that can handle that very well. Here are a set of examples. We have many, many more, but here are the ones would recommend today: Garrett Technology, Optimal Designs, Jabil, Lindell. They've all proven that they can handle this mechanical challenge and help with questions like, how do you address the cartridge assembly questions? So, for example, if your cartridge is assembled on one side, the host is assembled on other sides, how do you build those challenge response pairs to test your, to program your host MCU? And now you talk about the part orientation when it comes into the manufacturing lane where the cartridges are being made. How do you handle the part themselves during that manufacturing lane? What type of glue do you use to glue the secure element in your cartridge? So they are able to do that. So if you are a partner and have those capabilities and not a part of our design partner program, we invite you to apply to the Microchip Design Partner Program. We have, I think it's probably microchip.com/partner. Apply to the program, very easy enrollment, and join the list of recommended partners. We'd be happy to have you. So how do you get started? We have those boards that I mentioned where it's basically a board that follows the microbus footprint from Microelectronica, and that has that UDFN prototype unit of SHA206. That's what's being soldered down on the board. It's pre-configured and locked with a prototype secret. So that prototype secret is there to prototype. You do not use this prototype secret in production. You want to make clear of that. It's capable of maximum counter use 1024. You can write and lock data slots. The ATSHA204 on the host unit in UDFN is available, and it's pre-configured and locked with a ATSHA206 prototype secret. So now you have a ATSHA204 on the host with the prototype secret that corresponds to the prototype secret of the ATSHA206 that will be in that board illustrated here to build and prototype your challenge response like described. It's, like I said, it's implemented as a microbus extension board. Most of the Microchip development boards are supporting this extension here. So from a software standpoint, you could use this board with a DM320118, the Trust Platform board here. That's the lower board here. Firmware update will be posted on the web page of the DM0118 when it's available. The key protocol modification allows for proper identification of the ATSHA206 via crypto-athlib. So key protocol is something that allows to talk USB 2I2C to our secure element here via the Cortex M0 SAMD21 that sits on main board here. And pretty much the same thing for the DM320118. It's a larger boards that also have that SAMD21, but now we're using the X Pro form factor connectors here. And of course, it's supported in our crypto-athlib. So talking about crypto-athlib, the latest release of our library, crypto-athlib, has support for ATSHA206, the C version only, no Python supports. We don't have the, presently we don't have support inside the Trust Platform Design Suite, which we talked about a lot as part of the Trust and Go, Trust Flex, Trust Custom program. It's not yet supported as of October 2020. Meanwhile, inside the package, the code examples that we make available, you'll find packet-based authentication and disposable-based authentication for your to get you started. So takeaways, we've tried to make things easier, trying to keep your onboarding easy with predefined use case. That's where we preload the prototype secrets for you, and try to accelerate your prototyping. Try to have simple and cost-effective tool sets. We try to simplify the flow by leveraging the Microchip secure provisioning service. By Microchip providing that, you keep yourself flexible to choose whatever contract manufacturer you want. And between you and Microchip, the only thing that is needed to ship to a contract manufacturer is the shipping address. Your keys will not be seen by the contract manufacturer, and certainly not by the end customer. So that's where a lot of the value lies here. And finally, we try to keep our secure element architecture agnostic with any microcontroller. I'd like to thank you for your attention, and Megan, if you want to wrap it up, it's yours.
Yeah, thank you for everyone for joining us today. We hope you found this session informative. Visit www.microchip.com/shieldup to view all upcoming sessions and watch past presentations on demand. Be sure to follow us on LinkedIn, Facebook, Twitter, Instagram, and YouTube for the latest news and updates. Thank you again for your time, and we hope to see you during our next session. Have a great rest of your day.